Hello class, welcome to another lesson. Today's learning goal is I can graph a proportional relationship. So let's get started. What equation represents this table? Okay, so we're going to first test to make sure that it's a proportion. And typically we do that with the formula y over x equals k. And we see that if every single one of these has the same constant proportionality. Now the exception to that is this right here, because we can't do 0 divided by 0. Okay, we can't ever divide anything by 0. So this, when we have a 0 for the x value, this is an exception. Okay, we don't have to test with this one. Okay. So our y value is the rent, our x value is the month. So therefore, we're going to start testing with this one, and this one. So the first one is 550 divided by 1, which is 550. We've done this one, which is hopefully going to be the same thing as 1,650 divided by 3. And that is also 550, so we're good there. So far proportional. And finally, we're going to test for 2,750 divided by 5. And that also ends up being 550. Okay. So our constant of proportionality is 550. So therefore, the equation that represents this is y equals 550x, because we use the formula y equals kx. So now we know that what the formula is. We can use that formula to graph the following equation. So we're going to graph this right here, y equals 550. Excuse me. So when x is 1, we plug in 1 right here, and 1 times 550 is 550, just like the table said back here. Okay. So we're going to put a dot at 1, comma 550, which is approximately, so these are going up by 200 each one. So this one right here, this line right here is 600. So 550 is just going to be a little bit below that. So, well, I don't think that's quite right. Let's move that a little bit higher. Like right there. Okay. 550. We're going to have another one at, if we replace that with a 2, x with a 2, we find that y, 2 times 550, is 1,100. So we're going to put another dot at 1,100. So again, these go up by 200, so 2, and oops. Let's move that a little bit over. Right there. Okay. Nope, there we go. But now we gotta move this one over. Let's try locking this. That way it doesn't move on us. There we go. So 550, 1,100. And then we got 3. If we replace this with a 3, you find that's 1,650. So we're going to do a point 1,650, so about right there, but let's move that to a little bit better right there. Okay. And as you can see, this is going to end up being a straight line. So let's make that a straight line. And remember back here we had 0, 0 as well as one of the points. So we can start out from the origin. 0, 0. We're going to move all the way through each one of these. Like that. Okay. So that is the graph of the proportional relationship y equals 550x. Okay. So, actually this is a little tall because times 5 is supposed to be 750, so it's a little bit more like that. Okay, so right here. So let's try another one. Again, we're going to test to make sure that this is proportional, and we can skip this one right here. So let's start with this one, and this one. Our independent variable is the pizzas. So this is the x, and this is the y. So we're going to be doing 18 divided by 2, which is 9. So we've done this one. We're going to do 36 divided by 4, which is also 9, so we're done with this one. So for our proportional, and 81 divided by 9, this is proportional as well. So therefore, our equation is y equals 9x. We're going to graph it. Okay. Here, we're going to graph this one, y equals 9x, so we start from the origin, because that's, again, where it was beforehand. We get 0, 0. We can do 218 if we want to, so let's just start with 218. 218 is about right there. We also know if we replace this with a 1, x equals 1, we get y equals 9, so let's do a point at 9, right about there. Okay. Then we got 3 and 27. So 3 and 27, probably about, right there. 4 and 36. Right, it's about here, and 5 and 45, which is definitely right there. So again, this is going to be a straight line starting from 0, 0, which is the origin, and go through all of these points. We are going to go right there. Okay, so this is a graph of the proportional relationship y equals 9x. Points to notice, again, in each proportional relationship that is graphed, the line must go through the point 0, 0, which is also known as the origin. If it does not, the relationship between y and x is not proportional. Okay? And this can be very easily seen by any equation of form y equals kx. When x is 0, it doesn't matter what k is. Anything times 0 is going to be 0. Okay, so 0, 0 is always a point that's going to be part of the graph of a proportional relationship. In a proportional relationship, when x is 1, the point 1 comma y represents the constant of proportionality, or the unit rate. In other words, when x equals 1, the y value is also the unit rate. But this is only in a proportional relationship. So if we go back to the first example that we did, notice how our equation for this was y equals 550x. And the point 1, 550, was part of that. Okay? Over here, we said that when in the equation y equals 9x, when x is 1, y is 9, and also notice how the constant of proportionality is 9 as well. Okay, so 1, 9, the point 1, 9 means that 9 is the constant proportionality. So let's take a look at an example of this. I'll pause here and determine which one of these represents a proportional relationship. The one that represents a proportional relationship is the one that goes through the origin, or 0, 0, which is this one right here. This is the only one that goes through 0, 0. Okay? So, our next thing to do is, what is the equation for this? So we need to find the form of y equals kx and find the constant proportionality. And we said that we can do that by looking at the point right here. Okay? This point right here is 110, okay? Which means that the constant proportionality, k, is 10. So therefore, y equals 10x is going to be our equation. Here we're going to solve, okay, and fill in this table using the formula y equals 10x. Okay? So if x is negative 1, 10 times negative 1 is in fact a negative 10. Notice how that's not on the graph that's shown. Okay, negative 1 would be over here, but it does exist, and it would be down here. Okay, we just didn't show it on the graph. You can have negative numbers with proportionality. Okay. Again, we said that anytime the x is 0, the y value is going to be 0 inside a proportional relationship. 1 times 10 is 10, 3 times 10 is 30, 5 times 10 is 50. Pause the video here and try to figure out which one of these represents a proportional relationship. Notice how all of these are going downwards, and that is perfectly fine. A proportional relationship can have a negative k value, or negative constant of proportionality. The only one of these that represents proportion is this one right here, and we know that because it goes through the point 0, 0, right there. Goes through the point 0, 0, right here. Okay. So let's take a look at that one. We need to find the equation for the graph, and again, that's going to be in the form of y equals kx. And we said that we can do that by finding the y value when x is 1. And the y value when x is 1 can be found right here, because this is 1, x equals 1, and we have this point right here, which is in fact 1, 5. So our k value is 5. So therefore, excuse me, negative 5. That is negative 5. So therefore, y equals negative 5x. And if we were to fill in this table right here, x equals negative 1, so negative 5 times negative 1 is 5. Negative 5 times 0 is 0. Negative 5 times 1, which we said was this point right here, that is negative 5. 4 times negative 5, which is this point right here, because x is 4 and y is negative 20, so therefore our table should read negative 20. And 11, which is not on this graph, okay, but we can use our equation to figure what that is. Negative 5 times 11 is in fact negative 55.